And we are back discussing polygons again because we didn't quite get to all of the things that we would like to talk about the first time. So let's discuss regular, irregular polygons today. But just before we get to that, let's just do a quick review from our last lesson on what makes a polygon to begin with. Well, a few characteristics. Let's start with the first one. We know that a polygon must have 3 or more sides. So for example, we know a triangle has 3 or more sides. Definitely a polygon. A square would be a polygon. A rectangle would be a polygon. A pentagon, an octagon, a decagon, a 10-sided shape would be an octagon. Or, would be a polygon. Octagon would be 8 sides. Now let's take a look, and we know that polygons can never have curves. So no curves. An example of that would be a circle would never be a polygon. Even though it's a shape we're familiar with, circle is not a polygon. Next, we should think about no extra line segments. No extra line segments. Now what that means is on the end of a shape, we can't, for example, if we have a square, we can't have some extra piece over here like that. That would not be a polygon. So that is no good there. And another one we have to remember, it has to always be a closed figure, closed shape. Now, for example, of a non-closed shape, we would know that would not be a polygon. It's missing a line segment there. So it has to be a closed shape. And finally, we are not allowed to have crossed line segments to be a polygon. And we're going to change the beginning of that. We're going to say no crossed line segments. So this shape here kind of looks like an hourglass, not a polygon. Okay, now that you have reviewed polygons, let's take a look at what makes regular polygons or irregular. Now you could think of this irregular as, think of it not a regular polygon. So basically, what is irregular, what is not irregular? So irregular versus regular. Well, regular, simply put, all sides are equal, all angles are equal. I wonder if you can think of a shape where all the sides are the same or they're equal and all of the angles are the same or they're all equal. Well, I'm thinking of a 4-sided shape. I wonder if you can think of the 4-sided shape I'm thinking of. I'm going to draw it here and see if you were thinking of the same shape. And yes, the square. We know that every angle is a right angle, all 4. And those are 90 degrees, and it has 4 equal sides. That is called a regular quadrilateral pentagon. So that would be a regular polygon. A square would be. Also, if you were to draw, let's say, and this is going to be a little bit of a challenge for me. We'll try to see if I can draw it. And it's probably, no, it's not going to be perfect. But we're going to pretend like every one of those sides are exactly the same and every single angle on the inside is exactly the same, even though it's not. We're going to pretend like it's perfectly drawn. That would be a regular hexagon. That's a regular polygon where all you have to remember, all sides and all angles are equal. If that is the case in a shape, it is called a regular polygon. Now, on the other side of that, let's look at what makes an irregular polygon. An irregular, and you probably just thought about it, but all sides are not equal. But I also want you to think, though, and remember that some of the sides could be the same, but all of them are not equal. There might be 1 or 2. There might be 4 that are the same, but 1 might not be, depending on how many sides. And then with that, all angles are not equal to each other. Okay, so let's go over an example of this. Watch this shape. I'm sure you probably would guess this four-sided shape I might draw. That is definitely a polygon. It's a rectangle, but notice this side is different from that side as far as the length of the side. So the sides are not equal. Now, guess what though? The angles are all still 90-degree angles, so they're all equal, but the sides are not all the same. So this would be an irregular polygon, and it's a quadrilateral, which is a rectangle, four-sided shape. Take a look at this, and I'm sure you probably have seen it kind of looks like a house, but it's five-sided, and we're going to draw that a little bit better here. Try that again. Let's draw a little bit cleaner. All sides, these two probably the same size, but these down here at the bottom are not equal to the ones at the top. So this would be an irregular pentagon, which is a polygon. So it's an irregular polygon. This would be a five-sided shape pentagon. Now just keep in mind, it's that easy. A regular polygon has all sides exactly the same, all angles exactly the same. An irregular polygon has all sides not equal, all angles are not equal to each other. Now, some of them can be, but they all have to be a regular polygon. Now, before we finish, and before I move on here, I realized I called the square a pentagon. Remember, a square is a four-sided shape, it's quadrilateral. For some reason, I called it a pentagon, if you caught that. So just remember, that was a mistake on my fault. Okay, let's go and let's look at one final thing I want to leave you with before I finish this video. And it's something called concave and also convex. Now, could be some words maybe you've never heard of, but I think after I show you this, it won't be real difficult for you to remember these. Now, I did you a favor by drawing all polygons. There's no confusing ones here. There's not one that's not a polygon. Every one of these is a polygon. Now, we're going to identify them just a little bit more in detail by defining if they're concave or convex. Simply put, concave is I'm going to start here. Convex. Convex is when every angle is less than or equal to 180 degrees. So you might be saying, well, what is that exactly? Every interior angle, that means every one, let's look at this one here, has to be 180, which is a straight line, or less than that. So you can think of it this way. This would be a 180 degree angle, straight across, looks like a straight line. Anything less than 180, that's less than 180, that's less than 180. Anything smaller than a straight line or equal to that shape, if every interior angle is less than that, it is a convex polygon. So let's take a look at this over here, all moving over the triangle. I do know, just looking at this angle like that, that's an acute angle, little baby angle. This one up here is an acute angle. This one is an acute angle. So this would be a convex polygon. I'm looking over here. This is a 90 degree angle on this rectangle, 90 degree, 90 degree, 90 degree. Those are all less than or equal to 180. They're all less. Actually, half of 180, which is 90 degrees. So this one is a convex polygon as well. Let's look over here at what looks like a hexagon, six-sided shape. All of these are less than or equal to, they're all less than 180 degrees. Slightly, not a lot, but a little less. That would be a convex polygon. Let's go back over to this, what looks like one, let's count 2, 3, 4, 5-sided is a pentagon. And it does look like every one of those angles is less than our straight angle of 180 degrees. So it would be a convex. Now you might know and have an idea just by looking at, I'm going to select a different color, just by looking at the end. Think of cave, like caving in. When a house caves in or a board caves in, it goes in. Well, at least one of the angles is greater than 180 degrees on a concave shape. Let's take a look at this. This is basically a 90-degree angle. This is a 90-degree angle. But I'm going over here to this interior angle, and that's larger. A straight line would go straight across here. That's bigger than 180 degrees. So we don't even need to look at the others because that is going to be a concave polygon. Remember, it's caving in. It kind of looks like the outside's caving in towards the middle. That creates the concave polygon. Now I'm looking over here. This one looks like it's a little less than 180, not a lot, a little less. This is about a 90 degree. This is definitely less. This is less, but then I get to this angle, greater than. And notice how it's caving in towards the inside. We would call that a concave polygon. So that's going to conclude our lesson. Think about those things we've talked about. And if you watched the last video and then this video, you should be really solid on polygons and how to identify them. Enjoy, and thanks for joining me.